see what the significance of data modeling. See, any data warehousing solution the major activities you perform will be like this. So first what we do is do something called warehouse management. Part of this warehouse management we have two steps. One is data modeling and the second one is implementation of data models. So that's the most important thing. I mean, most of the people are not able to differentiate between what is data modeling and implementation of data modeling. So that we are going to discuss in detail with. Then the ETL process. You extract data from different sources, transform and load the data into the database. And finally, you design the reporting. See, of all these activities, your role actually will start from here, implementation of data models. Implementation of data models, ETL reporting is generally a development consultant responsibility or an implementation consultant responsibility. In SAP Hana, we also call them as modeling consultants, but actually data modeling, that first task will be done by the modeling architects. Data modeling is a task performed by modeling architects. So those modeling architects should have experience in business analysis, and they should have experience in modeling also. So only those people will be authorized to perform that data modeling. So what is the difference? What is the difference between data modeling and implementation of data modeling? Generally, what happens in the company is someone will come to you, give a specification saying that you create this object. Say, suppose you are working for PW, and you'll be asked to create so and so info cube. For that, you need to create some info objects. So when they're asking you to create an info cube, you should know what is the significance of creating that info cube in that system. Similarly, in HANA database also, you will be asked to create information views. And they'll ask you to create information views, but we should know what is the significance of creating information views in HANA. We cannot blindly create what they ask. That's where the data modeling is important for you. So not only learning how to do the things, we need to understand why we need to do it. So that's what is related to data modeling. So in simple terms, remember this. Data modeling is nothing but identifying the objects to be created, whereas implementation is nothing but creating those objects. So example, for a particular organization, you want to provide a solution, OLTP or OLAP, the first thing what you will speak about is database design. Database means what? It's all about tables. So the point is, how do you know that what are the tables you have to create? Will the company people provide you the details about the tables to be created? No, they don't do it. Because they are not technical people. We can't expect any information like that from them. So that's our responsibility. The information what we can expect from the company people is, the customers is, they can provide you the details about their business process. What are the business process running in the organization, those details they can provide. And apart from that, if it's analytical solution for each business process, what kind of analysis requirements they have. So, it is our responsibility to identify the objects to be created. Means it's our responsibility to convert your business into corresponding database objects. So that process of converting your business process into corresponding database objects, that's what we call it as data model. So in simple terms, definition is like this. It's a process of converting a business process into corresponding database objects. Why I am saying database objects is they need not be only tables always, they can be tables or they can be views. So a lot of importance we have for views in Hana. We will see what is the significance of views. So how do you do this? How do you do the conversion process? It cannot be done in a single step. We are saying it's a process. So basically the data models we follow depending on the requirements. So the data models we follow may vary. Suppose it is a OLTP system, purpose is transaction processing. If it is a OLTP system, purpose is analytics. So obviously models will vary. So for analytical solutions or data warehousing solutions, usually follow data models to be like this. We start with ERM, entity relational model, which will be converted into multidimensional model, which in turn is represented by a star schema. Generally you observe any warehousing solution they speak about implementing multidimensional models or star schemas. So what are these? What are these models and what is the purpose of those models? Let us discuss. Anyhow, you don't worry much about this, try to understand. It's the responsibility of the modeling architects to perform all this. Your task will be implemented. So, first step will be always we need to identify the business process. Process wise you have to do it. Example, you take sales. Then let us perform ER modeling for the sales process. So ER modeling purpose is basically, the significance of ER modeling is it's a graphical representation of the business process. So that way you can understand the business process easily and we can analyze the business process easily. So that's why always the first step will be business process we need to represent graphically. So how do you do that? There are a few simple steps for that, for this ER modeling. First, we need to identify the entities. What are the entities involved in the business process we need to identify. Then we need to identify relations between the entities. And then we need to find out attributes of each entity. and show them graphically. The standard notations will be there, you need to follow that. So let us take a small example. This is common for any warehousing solution. So if you consider that sales example, if you see the entities involved in the sales process, so you have entities like customer, material, salesperson. You know what an entity is? The thing of your interest related to that business process which is having its own properties, its own attributes is called as an entity. The only criteria is it should be related to business process and should have its own properties. That's an entity. So now we are speaking about sales. Customer is an entity, material is an entity. The salesperson or the sales employee who is involved in that business process is also an entity. And apart from this, there are so many other entities. Even material group is an entity. Material type is an entity. You have sales organization is an entity. A lot of entities will be there, and apart from that, there will be one common entity for every business process called intersection entity or transaction entity. Because every business process there will be a transaction. Like for sales, you have sales order creation. Order is nothing but transaction entity or intersection entity. So something like this. Customer, material, group, sales organization, salesperson, and sales transaction, which we call it as intersection entity. The reason why we call it as intersection entity is whenever this transaction is performed, all these entities like customer, material, salesperson, all of them are involved here. That's why we also call it as intersection entity. And one more thing, you can observe one important difference. If you see this, material is an entity, material group is also an entity. But there's a difference between these two. If you see material group on its own is an entity, but it's an attribute for material. And more importantly, this material is involved in the transaction but not the group directly. This material entity is involved in the transaction but not the material group. Similarly, salesperson is involved in the transaction but not the sales organization directly. So then we need to find out, actually the difference is those entities which are directly involved in the transaction, we call them as strong entities. So those strong entities only they have shown here. And here the final diagram they are showing them with some dotted lines, see that? Clearly differentiate. Because that will be helpful for converting this ER model to multidimensional models. Okay, we'll come to that. And then you need to find out the relations between these entities, like, cardinality relations like one to one, one to many, many to one, many to many. Those relations you need to find out and show it graphically. Like customer to material, many to many, you have material to salesperson, many to many. Here if you see material group to material, one to many, like that, you find out those cardinality relations and show them graphically. And then attributes also we need to find out all the attributes we need to show. Attributes means properties. And moreover, remember every entity will have one key attribute. Like customer is having attributes like customer ID, name, city and all that, whereas customer ID is a key attribute. Key attribute is nothing but attribute which will be used to identify that entity. So all those attributes are shown. And more importantly, attributes of intersection entity. Intersection is nothing but your sales order. Sales order What are the attributes we have? All of them need to be shown, like order date, order number, document numbers, then your customer ID, salesperson ID, then your material ID, how much quantity. These are important. It's quantity, amount, prices, and all that. Everything, every single information you have about that business process need to be shown graphically. Anyhow, we have some tools also available, like Erwin, which will allow you to design these ER models easily. Otherwise, they can refer to an existing ER models in the company. If already they have some application developed and they have that ER model already available in that application, that also they can use for referencing purpose. So finally, if you consider your sales process, it's shown graphically like this. Okay, and a couple of more considerations at the time of this year modeling. One thing always we need to remember that is warehousing, whatever the warehouse you are designing. That warehouse should be capable of storing the data coming from multiple sources. Generally in any company you have multiple source systems, data sources we call them as. So we have to identify how the data is maintained. This data is maintained in the data source systems, and accordingly we need to design this warehouse. The reason why I am telling you that is, suppose without knowing how this data is maintained in the source systems, you design this warehousing system. Say example, customer entity, you identified say 12 attributes. So tomorrow in the warehousing database, you'll have a customer table with 12 attributes. When they start loading the data, suppose there are 3 source systems. First source system is having customer data with 10 attributes. Second source system with 12 attributes. Third source system with 15 attributes. If you don't know that, while you are loading the data, you'll be able to load first source system and second source system data successfully. But when it comes to third source system, you'll be able to load only 12 attributes or 12 columns data. The remaining 3 columns they need to skip because your warehousing cannot store that data. And again you need to think about remodeling and all. And that's a lengthy process and very expensive for the company. So you cannot skip that information because that may be the information which is required for your analysis. That's why you need to be careful. You need to consider even the source systems also, how this data is maintained in the corresponding source systems, because based on that, if you do the designing, you'll be able to store the data coming from multiple sources. And one more thing is, there may be some attributes here in this ER model what we did. There may be some attributes which may not be used for analysis at all. Even though those attributes are not going to be used in analysis, we need to show them here in this ER model. But later on, when we convert this ER model to multidimensional model, those kind of attributes can be eliminated, suppressed, because that multidimensional models are exclusively for analytics. So that's what you need to do. You need to find out the strong entities, your intersection entity and the respective attributes, along with the relations between them. So once you're done with that, our requirement will be next, we need to convert this into multidimensional model. So ER model needs to be converted into multidimensional model. So what is this multidimensional model? What is the significance of multidimensional model? Why will people always will go for that multidimensional reporting? See, multidimensional reporting will give more options when you want to perform analysis for a particular business process. How it will give? What do you mean by multidimensional? Say example, a small comparison we'll do here. So you have OLTP system. Any OLTP system you take, OLTP system, how do you maintain the data? We store the data in the form of tables. We know that. That's nothing new for us. Generally in OLTP system, what are the analysis we do? We call it as two-dimensional analysis. I'll tell you the reason why they call it as two-dimensional. So you have tables. You know, table is always two-dimensional. Combination of rows and columns. Obviously it's two-dimensional. So what I'm doing is, from this table I'm just reading the data and designing a report. So as I'm reading the data from a two-dimensional table here, maybe one table or 10 tables, doesn't matter. Reading the data from a two-dimensional table and doing analysis by using the report. So obviously that analysis is only two-dimensional. Okay, so that's good, but how about multi-dimensional in OLAP system? Generally in OLAP reporting they call it as multi-dimensional. But how do you make that as multi-dimensional? You know, even in OLAP databases also, OLAP also we store the data in the databases in the form of tables. It's nothing different. Only difference might be the number of tables. Because of the normalization we have in OLTP systems, you may have more number of tables. Because of denormalization in OLAP systems, you may have less number of tables. But ultimately it's tables. So if you have just tables and you do reporting on top of tables, even this analysis also should be two-dimensional. So then how do you make your analysis as multidimensional? Remember one important point, data is always saved in the form of tables. Tables are always two-dimensional. Meaning of that is, I can store the data only in two-dimensional way. I cannot store the data in a multidimensional way. So there is no way we can store the data in a multidimensional way. So then what is multidimensional? Multidimensional is the way of presenting the data. It's a very, very important point, you remember this. Multidimensional is the way of presenting the data or representing the data, not storing. So to understand that, simple example you take, suppose there is a picture on the wall. You are watching it directly. Just imagine how it's visible to you. Whereas the same picture, the same image, you are watching it through a transparent cube. Take a glass cube, put it between you and that image, the picture, and watch it through that transparent cube, a glass cube. Feel the difference. What is the kind of difference you experience? You can see the difference clearly. You know, when you watch that image through a cube, cube is having different dimensions. In each dimension, that image is presented to you differently. The same thing here. Your data will be same, but when you try to present the data, we want to present the data in a multi-dimensional way. So how do you do that? For that, in between the tables and reports, we need to have an intermediate object like cube. So they have this cube concept in some of these warehousing systems, and here in HANA we have views concept. So how do you make your analysis as multidimensional? You can make your analysis as multidimensional only when there is an intermediate object like a cube or a view in between the reports and tables. Okay, so that's the most important thing you need to understand. So, people will speak about cubes in BW, but they'll say that I'm loading the data into cube, but never say that cube is storing the data. Cube never stores the data. For a cube, there will be underlying tables. Those tables are storing the data. But cube will be able to present the data because that will act as an interface even for reporting also. We don't do reporting directly on the tables, we do reporting on top of that cube. So same concept is implemented in HANA by using this concept called views. To be more specific about it, we call them as information views. We'll discuss on that. So now generally when you say multi-dimensional model, obviously we need to find out what are those dimensions you want to have for analysis. So identifying the dimensions. So based on the dimensions you need to analyze the facts. That's what multi-dimensional model is all about. So the conversion process is like this. From ERM to multi-dimensional model. Entity relational model to multi-dimensional model. The conversion process is the strong entities in ER model are represented as dimensions in multi-dimensional model, whereas intersection entity is represented as facts. So multi-dimensional model is nothing but analyzing the facts based on dimensions. It's nothing but your multi-dimensional model. So between the dimensions and facts there should be relation, then only we can do that analysis. So that was the conversion we can do here. We can see that conversion process. This is your multi-dimensional model. So these are the number of dimensions, these are the facts, and to maintain the relations we use these keys. So then only we will be able to analyze these facts like quantity, price, amounts based on dimensions. I can do analysis, sales quantity analysis based on the material dimension, customer dimension, sales area dimension, time dimension, whatever I want. See this conversion process, I'll show you here. This strong entity is represented as this dimension, this strong entity, this dimension, this strong entity, this dimension, like that. So they added time dimension also because generally any analysis we need time. We'll have that flexibility. These are not rules as it is we have to follow. When we do modeling, we have that flexibility of changing as per our requirements. That intersection entity, nothing but your sales transaction, is represented as fact. Instead of salesperson, they want to have analysis done sales area wise. In the place of that, they are using sales area dimension. So these are all dimensions for that cube or that view for multi-dimensional analysis. So you find out that in some of the warehousing solutions, these multi-dimensional models, we implement them as it is. Best example is in our Hana, we implement multi-dimensional models as it is, like as you are seeing it here. But some of the warehousing solutions, what they do is, they convert this ER model to, multi-dimensional model to star schema. There is a bit of confusion for most of the people here. What's the difference between multi-dimensional model and star schema? Actually, both are same. If you just convert these into tables, that becomes star schema. Means these dimensions into dimension tables, facts into fact table. just need to convert the dimensions into dimension tables, facts into fact table. That is nothing but star schema. So, what's the simple definition of a star schema? Combination of dimension tables and fact table is called star schema. This is a simple definition. So you can see that here. The dimension tables and fact table combination. This is what star schema. What's the meaning of that? It's nothing different from a multi-dimensional model. We can say representation of multi-dimensional model at the database level is star schema. It's just star schema. It's as simple as that. Okay, so if you see the definition what we have written, you can understand what exactly we are trying to do. See what we are saying, data modeling is a process of converting a business process into corresponding database objects like tables. So we started with a business process called sales, we ended with some tables here, dimension tables and fact tables. That's what data modeling is all about. Now you'll come to know that these are the tables I need to create. So you create those tables either directly or indirectly. So there is a reason why I am saying directly, indirectly. So sometimes in some of the warehousing solutions they may not create these tables directly. This example, BW. We'll come to that and we'll discuss on that. Similarly, some of the warehousing solutions, as I told you, like Hana, we don't need to go to a level of star schema, we can just directly implement multi-dimensional models. So what modeling architects will do is they'll just identify, so these are the objects you need, these tables or these views, these cubes. That identification only is their responsibility. They don't create them. Creating those objects, once modeling is completed, that's what we call it as implementation of data models. So implementation may vary from one environment to another environment. Because I can create table in Oracle in one way and the SQL Server different way, but ultimately I am creating a table there. That's matter of fact. Okay, so the means of doing it might be different. Say I can provide a data warehousing solution using BW, I can provide data warehousing solution by using Hana, but they are different things. But final result will be same. The goal will be same. But the way you do implementations need not be same. So that's why the difference will be modeling is common everywhere in every warehousing solution. It never changes. If I say warehousing solutions follows star schema, then follow star schema. If not star schema directly, multi-dimensional models. Both are same. So to understand that, let us differentiate between two things here when it comes to implementation. Say if you have SAP BW, how they do it, and the same data model if you want to implement in HANA, how do you do it? First you try to differentiate between these two. The difference is BW is an application. Meaning of that is, you as a consultant, you never connect to the database directly here. You'll always work at the application layer. So you have GUI, graphical user interface, which will allow you to connect to your application. That is BW. Application in turn is connected to database. Underlying there will be a database. This database can be anything. It can be Oracle. We are not worried. It can be DB2. It can be MS SQL Server. So in SAP BW, multi-dimensional models. In fact, it's star schema here. Implemented by creating something called info cubes. Just now I told you what is the significance of these cubes. They can allow you to represent the data in a multi-dimensional way. So by creating objects called info cubes, we'll be able to create, implement multi-dimensional models in BW, or star schemas we can implement in BW. But where do you do this? This cubes creation you will be doing at the application level, not at the database level, because no one is allowed to connect to the database directly here. So whenever you create a cube at the application level, what system will do is, system generates tables. You know what are these tables are? These tables are nothing but dimension tables and fact tables. Okay, system generates dimension tables and fact tables in the underlying database. So I'm not worried whether it is Oracle or DB2 or SQL Server. The way I'm going to create cube is same. So system will simply generate the tables for us. So that combination of dimension tables and fact tables only we are calling it as task. That's why you remember database layer is an abstraction for you there. But when it comes to Hana, it's not like that, because Hana itself is a database. We don't have any application here. It's basically a database. Means you are working with the database directly. So you cannot do like whatever you do in BW. Okay, so the difference is here multi-dimensional models, directly multi-dimensional models, now star scheme, are implemented by creating something called information views. Views only, but we call them as specifically information views. Don't say simply views, information views. One information view can be used for representing multi-dimensional model. Just for understanding something like this. So this is your multi-dimensional model if you observe. So this information view, how do you create it? How do you create views? Views are created based on tables. Without tables you cannot create views. But how do you get the tables in Hana? There in BW we are saying tables are generated, created by system. But here these tables in Hana either created manually or replicated from the source systems. Generally we go with the replication. No one will create them manually. We will replicate these tables from the source system. See, that's the clear difference. Ultimate goal is same, but the way you do implementations is different because of the environments are different. That's why even though the steps what you perform are same, but order is not same. See this? In PW what we do, anyhow we have to start with modeling, then we implement data models. When we implement data models, tables are created in the underlying database, perform ETL, load the data into those tables, and finally do reporting. See, this ETL, when you say, we say load data into InfoCube, but actually, even though if you say I'm loading the data into InfoCube, data will be stored in the underlying tables. So here do reporting on InfoCubes. That cube is like as an interface file. When it comes to Hana, same steps will be performed. We'll start with the data modeling, but we cannot implement data models unless otherwise replications are done. So ETL or replications, we'll say replications we need to perform. Use this replication technologies and perform replication of the tables into Hana. Once you get the tables replicated, then only you go for implementation of data models. And finally, implementation of data models here by creating InfoCubes. But here implementation of data models by creating information views, and finally reporting on information views, not on the tables, information views used for report. That's the difference. This is the most important differentiations you need to understand. It's very, very critical for us. In both the cases, if you observe whether it is an InfoCube or information view, we have underlying tables. In the case of PW, those tables are automatically generated. Here in the case of Hana, we are replicating those tables from the source system. That's why that steps order is different. In Hana, we do replications first, then models will be implemented. In PW, first models are implemented, then replication is done. I mean ETL is done. Okay. That is general warehousing concept, what you follow in BW, but this is a slightly different way of doing implementations in Hana, because we are working with Hana. Generally in databases they don't give these provisions of implementing data models, but this is case with Hana. And that too, you build the models in Hana, you do reporting on top of those models directly, as the total processing performed in database layer only. Performances will be very, very high when it comes to Hana as warehousing solutions. Ultimate aim is that not only just providing solutions, but you want to provide that solutions with high performances. Now you should be able to understand. Tomorrow if I ask you to create information views in Hana, you should be able to understand for which purpose I am creating that information views. What is the significance of that information? And someone is creating a cube in PW, you should understand what significance of that. Now you can understand it very easily. Okay, got this. So based on this, practically how to work with this views creation and all that we can discuss.